Hello children, welcome back to my channel. I am now dealing with the 6th class maths symmetry topic 12.1 exercise. These are the figures which you have to do in the book children. Check whether the given figures are symmetric or not. Draw the lines of symmetry. So here you have to see these are the figures that are given. So whether they are symmetry or not, you have to see and draw the lines of symmetry. So see here children, this is symmetric figure. So you have drawn the figure. Line. This is line of symmetry. Now this is also symmetric, but it is not a symmetric one. So you cannot draw any line here. And this one is also a symmetric. And this is also symmetric. And this is also symmetric. How can you say that it is symmetric? Because you can draw a line which divides the figure into exactly two halves. Here if you see, if you draw a line in this way, you don't get symmetric. Even in this way, you don't get similar figures. So these all are whatever I have ticked are symmetric. What I have not ticked is not symmetric children. This is first problem of your exercise 12.1. Now second problem. Draw the line of symmetry for each of the figures wherever possible. This is telephone, it has got only one line of symmetry, and butterfly, it is also having one line of symmetry, and this figure has two lines of symmetries, and a face will be having only one line of symmetry, and even this figure has only one line of symmetry, because here only these two are equal halves. In any way you do, you would get them as equal halves. Next, even this also is having one line of symmetry. Now the third question here, in the figure L is the line of symmetry. This is line of symmetry. Complete the diagram to make it symmetric figure. So in case if you get this kind of figures children, just you understand what is the distance here. You have to keep a point at the same distance, means by using the scale find out what is this distance. At the same distance I have kept a point here. Similarly, what is the distance between this point and this base? Same way, at that point I have kept another point and I have joined them to get a symmetric figure. This is how it is very convenient for you to draw the symmetric figures. Now fourth one is complete the figures such that the dotted line is the line of symmetry, means you need to draw the second half on the other side. So this is how I have drawn children. Be carefully if you take the figures which are given to us, same way you can draw. So these are the ones. So these are the problems that you have got in this exercise. Next exercise we will be doing. Now children, exercise 12.2, and in this the question is this. The first one is, write any 5 man-made things which have 2 lines of symmetry. So 2 lines of symmetry for man-made things. See, blackboard, sponge duster, notebook, ruler, writing pad. These all are having 2 lines of symmetry, children. So you can write anything else, but I have written this. It's your wish. Next, second one, write any 2 natural objects which have 2 or more than 2 lines of symmetry. Natural objects means which are not man-made, you know that. So what are they? Watermelon, muskmelon, orange, guava, papaya. So these are the things, these are the natural things which are uh, having more than 2. See, watermelon 2, you can say. Muskmelon, it's like a circle, more than 2. And orange also more than 2. Guava, you can say 2. Papaya also 2. Okay. Now let us see the next part. The next part of this is first and second questions of 12.2 I have already done. Then the fifth one is, find the number of lines of symmetry for the following shapes. See children, I have drawn this. I have taken a copy of the paper and I have drawn these lines of symmetry. So you can see here, you have got everywhere. Every line is dividing this into two equal halves. Here it has only one, here it has two, here there are no line of symmetry, nothing. You cannot divide it into two halves. And here you have got, these are the lines of symmetry. Here also you have got lines of symmetry. Next, draw the possible number of lines of symmetry. So this is equilateral triangle. So equilateral triangle will be having three lines of symmetries. Isosceles triangle, only one because it has only two sides equal. Scalene triangle, it has no lines of symmetry. And this is rhombus. Rhombus has got two lines of symmetry. And hexagon, it has got 1, 2, 3, 4, 5, 6 lines of symmetry, children. This is each line can be divided into two. See, line segments 1, 2, 3, 4, 5, 6 line segments are there. Each line segment can be divided into two halves. Apart from that, you have got, this is one more line of symmetry, and here this is one more line of symmetry. Wherever this is one more. Wherever the opposite vertices are there, if you join them also, it becomes a line of symmetry. Means not only the midpoints of the sides, if you join, you will be getting, but also vertices, opposite vertices, when you join, you are getting lines of symmetry. And if you see the circle, infinite number of lines of symmetry you can draw, children. Few I have drawn. Remaining infinite number of lines of symmetry you can draw. Basing on this figure, you have got a problem here. You see, children, third one. From the above problem, complete the following. Equilateral triangle. How many number of lines of symmetry? See here, how many are there? This is 1, 2, 3 are there. So equilateral triangle, I have written three lines of symmetry. Isosceles triangle. This is isosceles triangle. It has only one line of symmetry. Next, scalene triangle. See, children, this is scalene triangle. No lines of symmetry are there for scalene triangle. So that is what I have written. Next, rhombus. So see the figure. This is rhombus. Rhombus has got two lines of symmetry. This is rhombus. Rhombus has got two lines of symmetry. And hexagon has got 6 lines of symmetry. And the next one, circle. I told you, no, circle, infinite number of lines of symmetry it has got. Now, sixth one, a few folded sheets and designs are shown, are drawn about the fold as given. In each case, draw a rough diagram of the complete figure that would be seen when design is cut off. So you have to draw. I have drawn roughly, children. You also can draw the same replica of it. Whatever you have got this side, the same thing you have to draw this side also. Similarly, this is a quarter of the figure they have given. You have to complete the square and draw the figures. So children, with this chapter is completed. I am going to meet you in the next video with the next chapter, children.